going over Module 5, which is Virtualization Setup. As an overview, we'll cover hypervisors, virtualized hosts, and virtual machines. On hypervisors, there are two different types of hypervisors. There's Type 1 and Type 2. Proprietary, open source, we'll also be covering them. And then we're also going to get into the consumer versus the enterprise and how they're going to be using virtualization in their network. Type 1 versus Type 2. Type 1 is a type of VM that you load onto a bare metal machine. This is where you have the core loaded, which is basically a command prompt, and then you have VMs loaded inside of that core. The purpose behind this is so that way you don't have external resources taking up your machine. Type 2, on the other hand, is where you have an operating system loaded, and then you have VMs loaded into that. An example of that would be VMware or maybe Hypervisor. Type 2 uses more resources. With Type 2, you have the operating system running, which is using its resources, and then you have a program running using resources, and then you have the VMs running, which are using resources. Whereas the other one, you have the core loaded, and the core isn't using hardly any resources, and then you have Hypervisor, which is just the command line. You're not having to utilize the GUI functions. And then you have the actual machines running, the VM machines running on top of that. Those are what's using the majority of your resources. Proprietary. Proprietary is a term used to describe a certain device or a certain software working with the same company. For instance, Mac. Mac is a big user of proprietary. Their cables work with Mac products. The iPhone works with the Mac better than it works with Windows. However, you have to have a specific cable to perform the functions. Another example of proprietary is where the source code is not offered to you. For instance, Microsoft Word. Microsoft Word is an executable, but the source code isn't given to people. And sometimes with proprietary, you have licensings or you have subscriptions that are associated with them. On the other hand, you have open source. And open source is where you're given this information freely, where you don't have to buy a specific cable to work with a specific device. For example, the USB micro is a connector that was used in a lot of mobile devices, phones and tablets. However, most vendors have moved away from that and have their own type of cable. But if you have that open source, then you're able to use them with any computer and with any device. You don't have to have their specific cable to be able to use it. You can buy the cable from anywhere. Another thing with open source is that the source code is available to you. For instance, Firefox. Firefox is available to you and anybody can take it and modify it and use it as needed. When talking about VM, you have consumer and enterprise. Consumers use VMs a little bit different than an enterprise would. For example, a consumer would not have as many operating systems loaded on their VM. They might have Windows and then other versions of Windows loaded onto it. Whereas an enterprise would have Unix loaded as a VM, as the core, and then have Windows Server 2003, Windows Server 2008 R2, or some other type of program running on it. Another thing with a consumer is it's not meant to support many users. Most people that have VMs at home, they run that instance for testing. They will take a program and install it onto a VM, see how the program operates and how it reacts, and then they'll delete that program or delete that VM versus installing it on their computer. When an enterprise uses VMs, they'll actually give their users a VM to work with instead of an actual computer. And a lot of time whenever talking about consumers, they're using Type 2, whereas enterprises primarily use Type 1. Next, we want to talk about virtualized hosting. In virtualized hosting, we have hardware-assisted, BIOS, CPU, memory, and NIC. The purpose behind hardware-assisted virtualization is to improve the user's performance. Hyper-V and VMware are the most common programs associated with virtualization. It utilizes the actual hardware that's inside of the computer to make the VM run better. And with hardware-assisted virtualization, it gives the user a better use of their time. They're able to see their CPU usage, or they're able to see how many cores they're using, or how much memory they're utilizing. This way they can manage their information better, or they can manage their resources better. BIOS. BIOS stands for Basic Input Output System. The purpose behind BIOS is so that way it's able to find all the hardware that your computer is using and put it in a clean sheet so that way your computer is able to utilize those functions to their full extent. Most of the time, BIOS is a preloaded software from the manufacturer, and it's saved on chips that are attached inside the motherboard. If you've ever heard the term flushing the BIOS, that means you're deleting your BIOS and installing a new BIOS. BIOS is also firmware, which we'll talk about later on too. The BIOS is used for a quick save of all the devices and all the peripherals that are on your computer, so this way it doesn't have to rediscover them every time. CPU. CPU stands for Central Processing Unit. It is the brain of the computer. And essentially, one core CPU means you're able to run one process at a time. But if you have a dual core, that means you're able to run two. Quad core is 4. CPUs run up to 12 cores. However, for the consumer, most of the time they use either a 2, 4, 6, or 8. Most of the time, the more cores, 12 and 8, are used with enterprises. And most of the time they're used on a server. Just because you have many cores doesn't actually mean that you have a strong computer. That just means that you're able to run many processes at the same time. With these 12-core processes, they might be 2.13 gigahertz, whereas your computer at home running at 4 cores is running at about 4 gigahertz. So you're able to perform the functions more, but you're not able to perform as many functions as a server can. With CPUs, it's very important to remember that each CPU needs a core. You can share cores with CPUs, but if you're sharing cores, then it will cause your VMs to run slow. So utilizing that to its full extent is very important.